Hi everybody, this is TheGreenFrog here, and welcome back to another math video. Today I'm going to be showing you the divisibility rules, aka rules you can use to find out whether a whole number is divisible by another whole number. So, for 1, it's anything, any whole number. So 2 divided by 1 works, 5 divided by 1 works, 1 is divisible, or anything is divisible by 1. By the way, the word divisible means that you can divide another number into it with no remainder. So 2 is divisible, or 6 is divisible by 2, but not by 5. So 1 is anything, 2 is the last digits even. So 24, 4 is even, so it would work, but 27, last digit's odd, so that would not work. The 3 is the sum of the digits is divisible by 3. Before I keep going, I got this off of a page on mathisfun.com. I'll leave the link in the description. So the sum of the digits is divisible by 3. So if we want to find out whether 9, 7, 6, 4 is divisible by 3, 9 plus 7 is 16, plus 6 is 22, plus 4 is 26. That's not divisible by 3, so that huge number is not divisible by 3. But if, for example, we do 7, 6, 3, 9 plus 7 is 16, plus 6 is 22, plus 3 is 25, and 25 is also not divisible by 3, so that wouldn't work either. But if we do 9, 7, 6, 2, on the other hand, 9 plus 7 is 16, plus 6 is 22, plus 2 is 24, which is divisible by 3. So this huge number right here is divisible by 3. 4, you make a number with the last 2 digits, and that number is divisible by 4. So if we want to find out whether this number is divisible by 4, take these 2 last digits, form a number. So you can't flip them, but just take these right here. That's 67. That's not divisible by 4, so that wouldn't work. But if, for example, we did 4, 8, 4, 4, 44 is divisible by 4, so that huge number is divisible by 4. 5 ends in 5 or 0. 51. 1 is not 5 or 0, so it's not divisible by 5. But either 40 or 45 both end in a 5 or a 0, so they are both divisible by 5. 6 is divisible by 2 and 3. So if you remember, 2 is the last digits even, and 3 is the sum of the digits is divisible by 3. So something like 36 would work, because 6 is even, and 3 plus 6 equals 9, which is divisible by 3. But for example, something like 38 wouldn't work, because even though it is divisible by 2, it's not divisible by 3, because 3 plus 8 is 11, which is not divisible by 3, so that would not be divisible by 6. 7. 7's a little tricky. You double the last digit, subtract it from the number foreign from the rest of the digits, and the result has to be divisible by 7. So this number, double this digit right here, that's 8, and then subtract it from the rest of the digits. So 4768 divided by 8 is 4760. So now we can continue the rule on that. Double that is 0, subtract is 476. Double that is 12. 12 from 47 is 35, and then 35 we know is divisible by 7. So that number that we started with a while ago, that I don't remember, was divisible by 7. 8, the number formed from the last 3 digits, is divisible by 8. So this number, 896, has to be divisible by 8. And I don't want to do that out and make this video take forever. So let's see. My calculator. 896 divided by 8 is 112. So that would be divisible. But if you did 4, 6, 7, 8, 9, 7, that wouldn't be divisible because those last numbers would not be divisible by 8. So 9, sum of the digits is divisible by 9. Sounds kind of like 3, doesn't it? So for example, if we take 46, 4 plus 6 is 10, not divisible by 9. So it's not divisible by 9. But if we take, like, I don't know, 801, sum of the digits is 9, which is divisible by 9. So 9 is divisible by 9, or 809, or whatever that, no, 801 is divisible by 9. 10 ends in 0. 10 is divisible by 10, ends in 0. 20 is divisible by 10, ends in 0. But 25 is not divisible by 10, doesn't end in 0. Couldn't be much simpler. 11, another weird one. You do the first digit minus the second digit plus the third digit minus the fourth digit plus the fifth digit. Keep going, and the result has to be 0 or divisible by 11. Now, if that result is negative, you get rid of the negative sign, meaning you're taking the absolute value of that number, and you have to see if that's divisible by 11. I don't know why it has to be so hard. So 1, 1, 3, 3, 4. 1 minus 1 is 0, plus 3 is 3. Minus 4 is negative 1. Negative 1, absolute value is 1. That's not divisible by 11, unfortunately. But it's going to be hard to come up with an example for this, but that would work. But like 1, 1, 9, 0, 2. I just came up with that in my head. 1 minus 1 is 0, plus 9 is 9, minus 0 is still 9, plus 2 is 11, and 11 is divisible by 11. So that huge number right there is divisible by 11. And our final one that I stopped at, 12. There are divisibility rules for other numbers, but you're probably not going to need them, and they're kind of tricky too. So 12 is divisible by 3 and 4. Well, if you remember, 3 is the sum of the digits is divisible by 3. And 4 is, you take the number from the last two digits, see if that's divisible by 4. So if we take, for example, like, trying to think, 1044, that would work, because 1 plus 4 is 5, plus 4 is 9, and that's divisible by 3. And then for the 4 part, 44 is divisible by 4, so that would be divisible by 12. But, like, I don't know, 2144 would not work, because even though 44 is divisible by 4, 2 plus 1 is 3, plus 8 is 11, and that's not divisible by 3. So I hope you enjoyed this video. I'll leave the link to where I got all these divisibility rules in the description. If I did make a mistake, I'm sorry, but I tried my best, and I wasn't going to spend an hour making this video. I kind of did it a little quick, but hopefully I didn't make any mistakes. And please leave a like on this video, show it to all your friends, subscribe to my channel to join the Frog Pond, and I will see you next time for another video. Goodbye!